In this video, we're going to take a look at the Model Mania Design Challenge from 2012. If you're unfamiliar with Model Mania, it's a design challenge held every year at SOLIDWORKS World where attendees are given a drawing like this, and they're tasked with creating the part in SOLIDWORKS both as quickly and as accurately as possible. Now, if that wasn't enough, when they're finished, they're given an additional drawing with a series of changes and tasks, usually including performing a simulation. So we're going to go ahead and look at creating this part, and it's fairly simple to create. It's really comprised of two views. The front view, which contains most of the dimensional information we're going to work with, and the top view, which removes several pieces or several areas of geometry from the front view. In addition, notice in the lower left-hand corner that a material has been specified. And this is because, as I mentioned, in Phase 2, you'll probably have to perform a simulation. So let's dive into SOLIDWORKS and look at that first. I'm going to go ahead and start by setting the material by right-clicking on the Material node inside of the Feature Manager tree. If the material specified is in your favorites, you can quickly grab it there by simply selecting it. Otherwise, you can go into the material library where you can choose from several different material types. In this case, we're going to choose plain carbon steel. Now, several things happen when you specify the material. The first thing you'll notice is the appearance of the part changes to look like the material it's made out of. Additionally, the crosshatch is set, so when you create any drawings of this part, the crosshatch in any section views is set properly. But most importantly, the physical properties of the material have been defined. This will be important when we do things like perform a simulation, calculate the center of mass, or the weight of a part. I'm going to go ahead and press apply to apply that material. You'll notice that as we create the part, that the material properties look that way. So let's look at creating the actual part here now. I'm going to start with everything that's on that front view, but I am going to go ahead and draw it on the right plane. The plane you created on isn't really important, and this is just a matter of preference. There's several places you could start here, but I'm going to go ahead and start with this circle up in the front left. Now, the dimension here is given to us as a radius value, so I'm going to go ahead and type in the diameter equivalent of this in this case. If you want to change this after the fact, you can always right-click on a dimension, go to the display options, and choose to change how it's displayed. Additionally, there's a series of circles down here on the bottom. One is a radius of 9 millimeters, and the other is a diameter of 9 millimeters. Now, I accidentally clicked and dragged that out, so we'll add that dimension. There's a copy of these same two circles over to the side here. You'll notice that I just draw these, and what I'm going to do is I'm going to add relationships between these to ensure that their sizes always stay the same. This way, if I change the diameter here, it'll change the diameter here. Additionally, I'm going to go ahead and ensure that these two circles are always horizontal to one another, and then add some of the dimensions that I know. For example, I know that this circle is 30 millimeters below the first one I created. Additionally, the distance between these two circles is 24 millimeters, and finally the distance from the front arc to the back arc is 100 millimeters. By adding those dimensions, we fully defined this geometry, meaning it's locked in place. All that's left is really to connect the dots between the rest of it. I'm going to go ahead and start up here on the top by drawing a line straight out, and now I want to quickly transition to a tangent arc. An easy way to do this is while you're still in the line tool, just move your cursor back to the end point of that line and drag it back out, and you'll notice that the line will change to the appropriate type. Then I'm going to go ahead and just snap this to the circle and then add the tangency relationship, and finally the radius to this arc. In this case, it's 100 millimeters. We're going to do something slightly different down here on the bottom by creating a three-point arc between these two circles. I'm just going to draw this. Now, I'll over-exaggerate this so you can see why I go back after the fact and add this tangency relationship. That always ensures that those lines are tangent to one another, and then all I have to do is go ahead and add the radius. Very similar in this case, we're going to go ahead and do something quite the same. We'll create a three-point arc between these two circles, and then again add the tangency relationships by simply window selecting the two, and then finally adding the radius dimension, in this case 50 millimeters. So I've created all the geometry from the front profile. I could go through the process of trimming all this geometry away, but you'll notice it's actually not necessary, because when we go ahead and extrude, we can use something something called contour selection. I can select different regions of my sketch and I can extrude just those pieces. So for example, if I also wanted to include these two circles, for example, I could grab those, and finally the internal region. Now in this case, I do want to make this a midplane extrusion, and we should enter the appropriate dimension value, which is 24 in this case. Remember, by creating a midplane extrusion, I'm keeping the origin of the part as well as the right plane right down the center. That'll be important as we go ahead and create this next feature. The next feature I'm going to create is the cut on the top. So I'm going to go ahead and do this on the top plane. I'm going to go ahead and start by simply drawing a line, and using that same technique we just mentioned, by being in the line tool, I'm going to move my cursor back, and I'm just going to drag an arc out and snap it to the edge of the part. Then we'll just add a few dimensions. I'm going to dimension from the edge of the part to the inside 8 millimeters. The radius of this arc is 20 millimeters. And finally, the distance from the end of that arc to the end of the part is 65. Now you'll notice one of the things I didn't do here is I didn't close this sketch off. I want to point out the fact that you don't always need to do this as long as your sketch terminates all the geometry it encompasses. Let's take a look at what I mean. When I go ahead and choose to create a cut with this and specify either a through all or a through all in both directions, SOLIDWORKS creates actually a cutting surface, and then it presents you with an area where you can specify which side of that surface you want to remove. The thing to keep in mind here is this surface needs to cut all the way through the part. If this endpoint fell short, this feature would fail, and you would want to look at closing the profile off. In this case, it works perfectly, and it allows us to be a little lazy and skip drawing those 2 extra lines. Now because this part's symmetric and I created a midplane extrusion, that means that the right plane falls down the middle. I'm simply, to mirror this over to the other side, going to select the feature in the right plane and choose the mirror feature and just right click to confirm. That makes that really easy to do. Finally, there's a cut going through the back side of this. To create this, I'm going to do something a little bit different. I'm going to go ahead and create a rectangle, and you'll notice I'm going to use this new option called Add Construction Lines, and I'm going to choose from midpoints. And in this case, I'm just going to draw it out here in space. I don't know what the length of this cut is going to be because it is specified from the center of the back arc, but I do know that the width in this case is going to be 8 millimeters. So notice I'll just snap that down. This makes it really easy because of these center lines to just drag and drop that onto the midpoint of that part. Now all I need to do is dimension to the end of this rectangle using the center of this circle. An easy way to find this is from the heads-up display enabling something called temporary axes. These are axes that are applied to every cylindrical feature in your part. This way I can just quickly dimension to the center line of that circle and specify that 35 millimeter dimension. When you're done, you can just turn those back off. You'll notice in my case there is also a hotkey applied to this that I've customized because I use this option quite a bit. Then let's just go ahead and take that profile and cut that through all in both directions to remove the material. The last step is to just go ahead and add a series of 2 millimeter fillets to this part. If you've watched previous videos in this series, you really know that I like to grab faces, because faces grab all the adjacent edges on the face, and with tangent propagation, quickly select all the tangent edges as well. So I'm going to go ahead, and for this, I'm going to select this face as well. We'll select this face here, and you'll notice how I'm quickly capturing a lot of the geometry. We're going to do this one here. Again, I'm going to select this face here, and then finally the inside face. When I right click to confirm, we can see that we get what was shown in the drawing. If we wanted to, for clarity, we could also go back and we could change the color of this feature by simply selecting on it and choosing the feature alone. And here we'll go ahead and set that as a red color so you can really see those and make those stand out. So we've created our phase 1 part. At this point, we would be given an additional drawing. When we take a look at this drawing, we can see that there's several changes to the cuts in the top, and notice how the termination of that cut actually goes into that cylindrical feature down in the bottom. We'll have to handle this in a slightly unique way. Other than that, most of the changes are going to be pretty easy to handle. While we're here, let's take a look at doing the changes in the front view first. These are probably going to be some of the easier ones to change. So I'm going to go ahead and I'm just going to roll my part back and take a look at where we were and choose to edit this sketch. Instead of having one continuous arc across here, we have an arc that comes up to a line. So what I'm going to go ahead and do, the first thing I'm going to do is I'm going to remove this tangency here. Well, let's go ahead and draw the line first, because I want to explain a few things as I go through this, like why I would do that. So I draw the line, and then I'm just going to go ahead and trim this material. But you'll notice I can't actually go through the process of adjusting this line. And the reason is because even though I trimmed that arc, this tangency relationship, not that one, this tangency relationship is still locking this arc to this arc here. We'll go ahead and delete that. And notice once I do this, I can just move this and snap this to the bottom of the arc. We do need to change the radius of this arc as well to 30 millimeters, and notice this subtle change. Instead of being defined as a radius of 7, this width of the top has instead been changed to a width of 12 millimeters. So the dimension has changed there. You could have just changed the radius to 6 if you wanted to as well, but I like to make my dimensions match what's on the drawing. So we've made those changes. I'm going to go ahead and exit the sketch. So far, everything's updated all right. When we look at this cut, a significant change happens here. We increase the depth of this cut to 85 millimeters. And that cuts into this round at the bottom here, which by looking at the drawing, we can see is supposed to extend out. Now, we could handle this right here, but I'm going to wait until after the mirror. And the reason I'm going to do that is because I'm going to do this all in one step. If we go back to the original sketch, you'll remember from that sketch that I had created these circles using contour selection. If you didn't, you could just draw a new sketch here. What I'm going to do is I'm going to select the region between these two circles, and notice what it captures. It excludes the hole and gives us that boss we're looking for. And because this faces the end of the part, we can just choose through all for our termination direction and enable direction 2 and get that all in one go. Now I could have done this before the mirror and extruded it in one way and then included the boss in the mirror as well. So you could have really tackled that 2 different ways. Additionally, this cut's changed. It's been reduced significantly down to 18 millimeters. So let's go ahead and change that dimension. And then as we take a look at our fillets, because we selected faces that didn't change at all, notice all the fillets just update for us. But it automatically captures these new edges that are adjacent to the faces we selected. So that's a really nice change there. Additionally, we do need to perform a simulation on this part. And to do this, I'm going to turn to Simulation Express, found in every version of SOLIDWORKS. When you enable this, if you haven't activated it, you will have to go to our website to activate it and get a free license for it, and then just walk through the steps. The first is introductory, so we'll go ahead and choose next. Then we need to apply a fixture where the part will be held in place. So I'm going to go ahead and choose to add one, and I'm just going to select all this geometry at once. You could do these individually if you wanted, but because in Simulation Express you could only create a fixed type, I'm just going to select them all at once. In SOLIDWORKS simulation, you could create many different types of fixtures. And then we're going to go ahead and move on to the next step. At this step, we want to apply a load to the top face. So I'm going to go ahead and choose to add a force to this top face, and you'll notice that it's given 500 newtons. So I'm going to go ahead and just press 500. Now in this case, you can see that the direction of the arrows is correct. It's going in the direction of the face. But say we wanted to go in a different direction. You could change those options here. But we're going to go ahead and keep what we have. So we've created our fixtures, we've created our load. All that's next is to apply the material, which we've already done. Notice that Simulation Express automatically captures the information it needs. If we wanted to make a change, we could do this here, but we'll just move on to the next step and run the simulation. SOLIDWORKS very quickly will go through and mesh the part and give us our results back. It gives us a preview of how the loads act on the part to make sure this is what we expected. It is in this case. When we go to the final results, we're immediately given the factor of safety. It's in the description down here. It's 2.43883, or we could just say 2.44 if we wanted. One of the nice things about the factor of safety plot is we could find weakest areas in our design by changing this value. For example, we could say, show me where it's below 3, and it's going to show us the weakest areas of our design. Now granted, a factor of safety of 1 or in most cases 2 is going to be what we're looking for. We could also at this point show the displacement of the part as well, and we could see where the maximum deflection takes place. And as expected, it does happen out on the end of this part right here. You could also capture these values. I should note, in SOLIDWORKS simulation, you can completely customize these charts and change the unit and display type. So for example, if scientific notation isn't your thing, you could just change that to decimal places and specify that. So that's it. We've gone through the SOLIDWORKS simulation, we've gone through the Model Mania Design Challenge from 2012. We've created the part, made the change quite easily, and performed a simulation on it. If you're looking at going to SOLIDWORKS World, it's rapidly approaching, and I highly encourage you to visit the link either below this video or in the blog post where this is hosted.